have you ever just stopped and thought about how connected everything really is? I mean, from your morning commute to the way you find new music, there's this invisible web of relationships that's kind of shaping your entire world. Today, we're going to pull back that curtain. I mean, think about it for a second. How does your GPS know in real time to route you around a sudden traffic jam? Or how does your favorite social media app seem to know exactly who you went to high school with, even if you haven't talked to them in years? It honestly feels like magic, but it's not. It's all powered by this brilliant and surprisingly simple idea. And here's the secret. The magic isn't in the individual pieces of data, the cities, the people, the products. Nope. It's in the relationships. It's in the lines that connect all those dots. Understanding these connections, that's the key. And the tool we use to do that is called a graph. All right, so let's get into how we actually model these connections. It's a way of seeing the world that is both incredibly powerful and, you won't believe this, almost laughably simple. And it all starts with this idea of a graph. So, what is a graph? Well, forget all the complex stuff. It's just a way of drawing a network. And it's only made of two things, nodes and the relationships that connect them. That's it. It's just dots and lines. But with these two simple building blocks, you can model pretty much anything. First up, you have your nodes. These are the things, right? The entities you want to connect. A really great way to think about them is as the nouns in a sentence. They could be people, places, products, whatever. They're the dots on the page. And then you have the relationships. These are the lines that connect those dots. And if the nodes are the nouns, then the relationships are the verbs. They're the action words that give the whole thing meaning, like a person knows another person, or a customer buys a product. Okay, you know what? Let's just build one right now. A super simple one. Imagine we have three nodes, three nouns. We've got person A, we've got person B, and we've got a car. Right now, they're just three separate dots, floating around with no context. But now, let's add the verbs. We draw a line. Person A lives with person B. Okay? We draw another line. Person B owns the car. Interesting. And a third line. Person A drives that same car. And just like that, we don't just have random data points anymore. We have a story. We have a real-world scenario that a computer can now understand. So once we have this map, this graph, we can start asking it some really, really powerful questions. And to do that, we use something called graph algorithms. Think of them like recipes for getting specific, juicy answers out of our network. And most of these powerful recipes fall into three main categories. First, pathfinding. What's the best way to get from A to B? Second, centrality. Who's the most important player in this network? And third, community detection. Are there any natural groups or cliques hiding in here? Let's start with pathfinding, because this is the one you use every single day, probably without even realizing it. It is all about finding the most efficient way to get from one point to another. Now, this is where it gets really cool. The word shortest can actually mean different things. So on the left here, the shortest path from A to E is the one with the fewest stops, or hops. Easy enough. But look at the right. If we add a weight to each road, like, say, distance or travel time, the fastest route might actually have more stops, but be shorter overall. Your GPS is doing this exact calculation every time you use it. All right, next up, centrality. So if pathfinding is about getting between the dots, centrality is about finding the dots that matter most. It's all about identifying the key players, the VIPs of the network. Think about what that means. A centrality algorithm can pinpoint the main airport hub where a single delay could cause chaos across the country. Or it can find that one critical bridge in a city that, if it closes, would cause total gridlock. Or, it can find the biggest influencer in a social group. And our third and final recipe is community detection. This is kind of like looking into a crowded room and instantly seeing all the different friend groups. The algorithm is designed to find these natural clusters where all the nodes are super connected to each other, but not so much to the rest of the network. This is the secret sauce behind so many recommendation engines. They find communities of customers who like and buy similar things. It's also how social networks find those organic friend groups to suggest to you. And on the flip side, it's also how investigators can uncover hidden fraud rings, finding criminals who are all working together. Okay, so we've covered the theory. It's cool, right? But now let's look at where these algorithms are absolutely changing the game out in the real world.
In business and logistics, it is a total revolution. Delivery companies are using pathfinding to slash their fuel costs. Airlines use Centrality to model their flight networks and stop those frustrating ripple effect delays. And banks, they're using community detection to spot these complex fraud rings that would be totally invisible otherwise.
And in tech, oh man, you're using this stuff every single day. Those recommendation engines, the people you may know feature, that is pure community detection and pathfinding. Even the way search engines work, they use Centrality to figure out which web pages are the most important and authoritative on the internet. And the impact in science and research is just staggering. Seriously, scientists are mapping how proteins interact to find cures for diseases. Epidemiologists are using it to predict how viruses will spread through our social networks. It's truly on the cutting edge of discovery. So let's bring this all home. Let's zoom out. Why is it so important to look at the world this way, through this lens of connections? Why does any of this matter to you? Well, here's the biggest takeaway. The crucial point is that real-world networks, whether we're talking about friends or biology or logistics, they're not just a random jumble of connections. They have a structure. They have these dense clusters and these super influential hubs. And graph algorithms are the perfect tool, really the only tool, that is specifically designed to find and make sense of that hidden structure. There's this fantastic quote by the computer scientist Stephen Skeena, and he just nails it. He says, "Graphs are one of the unifying themes of computer science. The fact that you can model so many different complex things, from friendships to flight paths, with just the simple language of dots and lines, well, that's an incredible source of power."
So I'll leave you with this question to chew on. Now that you know what to look for, the nodes, the relationships, the paths, the hubs, what hidden networks can you suddenly see shaping your world?